Hi class, for this video, I want to talk about polar coordinates and rectangular coordinates. So we know the rectangular coordinates really well, which is x, y, the x-axis and the y-axis. But since we're talking about trigonometry here, so we're going to have to take care of polar coordinates. So the polar coordinates is r and theta, gives the location of a point P in the plane. So note that r is a real number and theta is an angle in standard position. So you can see the values of r gives the distance of the point from the origin. And if r is positive, then the point lies on the terminal side of 0. R negative, the point lies along the ray opposite of the terminal. So it's right here when r is negative. When r is positive, it's up here, which is just a terminal side. Okay, this is the terminal side, but you have to take the opposite of the terminal side if r is negative. All right, so we know that in a rectangular coordinate, each point in the plane has only one order pair, one x, y, right? But in a polar coordinate system, each point has more than one representation. So for example, I can have something like that. So let's say this is 40-degree angle and this is 7. So you see right here, this is my polar coordinates, 7, 40-degree. However, if I have this angle right here, I'm talking about this angle. Okay, so this is negative 140-degree. But if I take the opposite, all right, then this point is also 7 and 40-degree, right? Or I can do this. Instead of just go 40, I can go one more round. Okay, so I can add 360 to it. I will get the same point, which is 7 and 400. So you see that one point, we have many representation for it. Now, when we convert a point from rectangular to polar, you're gonna have to be very careful with Q. So Q1, 2, 3, and 4. It's gonna give you different answer. So straightforward. So if the point lies on the x-axis or the y-axis, then we find r theta by looking at this graph. Very easy. But if the point lies on Q1 or Q4, then we have r equals to, r is always square root of x squared plus y squared. But then theta, you can do tangent y over x. But if we're in Q2 and Q3, you have to add 180 to theta. All right, so let's try a problem right here. So we have to find the polar coordinates of that point, -2, 2. So first of all, let's find r. R is going to be x squared plus y squared. So in this case, it's going to be -2 squared plus 2 squared, which is 4 plus 4, which is 8. So if I simplify it, it's going to be 2 rad 2. Now, so what, okay, where is negative 2, 2? Negative 2, 2. Negative 2, 2 is right here, right? So this is Q2. Okay, so don't forget for Q2 and Q3, for the angle, we have to add 180 to it. So theta is going to be tangent, I'm sorry, arctangent of y over x, but then we add 180 to it. Okay, so you just have to plug it in. Tangent two over negative 2. We plus 180 to it. So this is tangent, arctangent of negative 1 plus 180 is negative 45 plus 180. So it's 135 degree. So your final answer is going to be R, which is 2 radical 2. And then the angle is 135 degree. Okay. All right, moving on. Now we have the opposite. So we have, this time, we have the polar coordinates, and then we have to find the rectangular coordinates. So what are we looking for? We're looking for X and Y. Okay. So here we go. So don't forget earlier, we know that cosine of theta is adjacent over R, which is X over R. And then we know that sine of theta is going to give me Y over R. Okay, so from there, we know that X is going to be R cosine of theta, and Y is going to be R sine of theta. Okay, so we just use these two equations and plug it in, right? So for X, R in this case is 3. Cosine of negative 7 pi over 4, I should put parenthesis right there, and Y is going to be 3 sine of negative 7 pi over 4. So from there, we just, you can use the unit circle if you want. So it's gonna be, we have 3 radical 2 over 2. And there we have it. Okay, moving on. Now, this time, instead of dealing with the point, we have an equation. So we try to convert an equation written in rectangular form to polar form. So you just have to use the formula that I have for you right there. They're all very similar, okay? So let's work with this one right here. So first of all, we know that we know that r squared is x squared plus y squared. So let's go back to our equation. Our equation is x squared plus y squared plus ax equal to 0. But we know that x squared plus y squared is just r squared. Okay, so r squared plus 8, and we know that x is going to be r cosine of theta equal to 0. All right. So based on the equation here, I can definitely take out the r because we want to solve for r. So I can just factor out r times r plus 8 cosine of theta equal to 0. All right, this is just purely solving quadratic equation, right? So we have r equal to 0, r plus 8 cosine of theta equal to 0. So r is negative 8 cosine theta. Now, note that the graph of r equal to 0 is the pole. And the pole is included in the graph of r equals to negative 8 cosine of theta. So we can just disregard r equal to 0. So we have that for the solution. All right, so that's how you solve for r. Now, let's take a look at the next problem. The next problem, I want to do, let's try the other way around. So if I want to convert a polar equation to rectangular form, so for example, I want to convert theta equals to 4 pi over 3. So I want to convert into rectangular form. So make sure that you know x equals to r cosine of theta, y equals to r sine of theta, r squared. You know what, let me just write down for you. X equals to r cosine of theta, y equals to r sine of theta, r squared equals to x squared plus y squared. Okay, all of that we need all of that to deal with the problems. And don't forget tangent theta is y over x. The reason we want to use tangent is because tangent dealing with y and x. So if we take the tangent on both sides, so I can take tangent of theta equals to tangent 4 pi over 3. So 4 pi over 3 is radical. If you go to the unit circle, you know that tangent of 4 pi over 3 is square root of 3. All right, but don't forget tangent is y over x. So I can take this and I can put it equal to y over x. All right, so y is square root of 3 times x. Now we have the rectangular form, y and x. Okay. All right. Let's try a different type. So I want to convert r cosine of theta equals to -2. So how do we do this problem? So don't forget that the relationship with x and r cosine. So r cosine of theta equals x, right? So you can see in this case, x is just -2. And then we're done. Okay? Yeah. So these are quite easy. Now, we can do something maybe a little bit harder. So let's try this. So I want to convert. And I have r equals 9 over 3 cosine of theta plus 8 sine of theta. Okay, so I want to convert this into rectangular form. Now, don't forget that x equals to r cosine of theta, y equals to r sine of theta. Now, every time I see fraction, I just want to get rid of it. So I can just multiply 3 cosine of theta plus 8 sine of theta equals to 9. Okay, now we can distribute. So we have 3r cosine of theta plus 8r sine of theta equals to 9. But we know that this one is just x and this one is y. So what we have is 3x plus 8y equals 9. And then we're done.